lecture, I will explain what is the necessity of starter. So, what is the voltage equation of a DC motor? So, the voltage equation of a DC motor V equal to EB plus IA into RA, and V minus EB divided by RA, that should be equal to IA. So, initially the speed of the motor will be 0. The speed of the motor, when the motor is switched on, it will start from 0. So the speed of the motor is 0 at initial condition, at start condition. The back EMF is equal to 5Zn by 60 into P by A, and EB is directly proportional to N, and the EB value is also 0. If I am applying 200 volts, that means the supply voltage is 200 volts, and RA is equal to armature resistance is 0.5 ohms. 200 minus 0 divided by 0.5, then your armature current is equal to 200 divided by 0.5, that should be equal to 4000 amperes. I think, right, 400 or 2000, yes, 400 amperes. The current is 400 amperes, but the machine rating will be the armature current, so is 20 amperes. How much extra current is flowing at the starting condition? At the starting condition is approximately equal to 20 times of rated current. The rated current is mentioned on the nameplate details of DC motor. So if this high current flows through armature winding, definitely armature winding will be burns. So that's why we require a starters at the time of starting. So that's why we are using 3-point starter and 4-point starter. So coming to the 3-point starter. So this is about the 3-point starter. And this is a handle. H is called the handle. Here L is the line. F is the field. And A is called the armature. And this is a no volt coil. No volt coil. I will use a different color. So initially, this handle at this position, there is no contact between the resistance and handle. So this is called the overload release. OLR is called the overload release, and NVC is called the no volt coil. Through this handle we are having a two parallel paths. See, this is a one parallel path, and the current is divided like this. One more parallel path. If the handle is at this position, the entire resistance R1 plus R2 plus R3 plus R4 plus R5 is connected in series with the armature. If IA is equal to V minus EB divided by RA, if I am adding an external resistance, definitely the current will be decreases. Current will be decreases. During running condition, this is not included in series with the armature. Once it will be at one position, entire resistance will be added. Directional resistance now, that should be equal to R1 plus R2 plus R3 plus R4 plus R5. So we are moving manually this handle from one position to second position. This R1 is gradually cut out. Now RE2 is equal to R2 plus R3 plus R4 plus R5. Then IA is equal to V minus EB divided by RA plus an external resistance is RE2 now. Once it will be shifted from one position to second position, slowly the speed will be increases. EB is directly proportional to N. Why? Because if IA is current is flowing through the motor, the force will be developed. So we know that the force is equal to BIL. And if I increases, the force is developed on the armature winding. Is increases, it will be rotates. Once back EMF comes into picture, the IA will be regulated. So after that, it will move to third position. Only R3 plus R4 plus R5. So R3 plus R4 plus R5 is included. And at fourth position, R4 plus R5 is included. At fifth position, R5 is included. And at run position, if you observe, yeah, at run position, you can observe only the armature resistance is included. Then IA is equal to V minus EB divided by RA. So this handle is moved against to the spring force, and the spring will be twisted in opposite direction. If this handle force will be in this direction and the spring force will be opposite direction, the spring force will be opposite direction. So this no volt coil is carries a field current. It carries a field current. The current which is flowing through, see here, and actually you can observe the current which is flowing through no volt coil, and so just like it is acts as a magnet, here the iron piece is kept on handle. Once it will be touched, once it will be touched to the no volt coil under running condition, this magnet will be attracts the iron piece, and it will be at remain at a stationary position. So that means in this position under running condition. And this entire resistance is included initially with the armature, but once under running condition, only the armature resistance is present. Okay, this is the importance of the no volt coil under running condition. So if any overload will be occurs, overload means suppose the machine rating will be 20 amperes. If it crosses 20 amperes, so what will happen? This triangular, if you observe this triangular is there, this triangular will be shift upwards. This magnet, whatever this piece, this piece is opted upwards, and the AB terminals are short circuited. Once AB terminals are short circuited, what will happen? It loses its magnetism because of restoring force of the spring. It will comes back to original position. So under normal operating condition, the position of this piece is like this. Okay, this iron piece is like this. Okay, and if you observe, once the power is off, also there is no current flowing through this no volt coil. If the current flowing through no volt coil is zero, definitely because of the spring force, it will comes back to original position. So this is about the 3-point starter. This is about the 3-point starter, and we can say that it is called as a triangular piece. This is in the shape of triangular piece. Once what is the disadvantage means, suppose if I am going for the field control means I am connecting an external resistance in with the field. So if the speeds will be evaporated, speeds will be possible. Why? Because speed is inversely proportional to flux. If flux decreases, speed is also increases. How the flux will be decreases? With the decreasing of field current. So no, the field V divided by SRF plus external resistance, or Rx. If Ix value will be decreases, what will happen? If you go for the above rated speeds, what will happen? The field current will be weakened. If the field current will be weakened, this no volt coil is not having a stamina, is not having attractive force to withstand this handle, this iron piece. So that's why we can go for the 4-point starter. In this 4-point starter, if you observe, whatever this field, the current which is flowing through the field is separated. So current flowing through the field is separated, and none current which is flowing through the snow volt coil is separated. You can go for the evaporated speeds, nothing is the problem. And we have a line N and F and A. So we have four terminals. So that's why previously LFA means three terminals. I have three terminals. That's why it is called as a 3-point starter. But in this case, four terminals have. That's why it is called as a 4-point starter. Okay, this N terminal is additionally it is added, and that is connected. See, if the current is coming like this, okay, current is diverted. Yes, current is diverted directly. The current which is flowing to the field through the no volt coil. So through the no volt coil, as the current is coming like this, and the current will be divided, and this will holds the handle. This will holds the handle by without affecting the current which is flowing through the field. So even though without affecting means without affecting the flux, even though flux is weakened, what is the meaning of this means with if the flux is weakened, there is no effect. There is no effect. So anyway, it is called as a spring. This is soft iron piece, and this one is spring, and this is a starter handle. We are initially moving from one position to fifth position or sixth position under run condition. So we are giving a 220 volts supply, and this is about the 4-point starter. Okay, and if you are going for the speed is inversely proportional to flux. If a flux is weakened, the speed will be dangerously high. Yes, sir. Dangerously high. So under this failure, the no voltage coil. So generally, if you go for if you go for the 3-point starter, what will happen? The speed will be dangerously high. Our flux is weakened, and it will comes back to original position because of its losing its magnetism. But if you go for the evaporated speeds, the speed will be dangerously high with the weakening of flux. This is about the 4-point starter. So I think you understood, guys. Thank you.